Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 28, 2025, just yesterday. This paper unveils an open, agentic large language model for long-horizon research that combines agentic mid-training and agentic post-training, delivering state-of-the-art results such as Humanities Last Exam about 33, Browse Comp about 43, and WebWalker QA about 72. The paper is titled Tongyi DeepResearch Technical Report, and as we will see later, the implications for training autonomous research agents are quite significant. Also, the authors shared a GitHub repo. You'll find the full DeepResearch codebase with agent and web agent modules, inference and evaluation scripts, a clear quick start and requirements, and .env example for tool APIs, benchmark runners, and model download links. It even includes Open Router usage to run inference without GPUs. Alright, the repository details were just covered. Figure 1 shows that Tongyi DeepResearch leads or ties leaders across multiple deep research benchmarks, signaling strong, real-world research agency. Average at 3 means the score averages across the best 3 attempts, which stabilizes evaluation for stochastic agents. On Humanities Last Exam, the score is about 33. On Browse Comp, the score reaches about 43. On WebWalker QA, the result is about 72. Figure 3 explains how the team synthesizes agent behavior across a full workflow, so the model learns to plan, decide, and reason in sequence. Agentic continual pre-training means extending general pre-training, with trajectories that teach tool use and long-horizon control. The dashed hidden process region captures multiple potential pathways that lead into an explicit decision-making step. The left question synthesis block seeds tasks. The right side shows reasoning steps that iterate before producing the final answer. Well, Figure 2 presents the end-to-end training pipeline that turns a general base model into a deep research agent. The left block shows pre-training on QN series base models, which provides broad language competence. The middle section illustrates 2 agentic continual pre-training stages with longer context, so the model practices long trajectory reasoning. The right section depicts post-training with supervised fine-tuning and reinforcement learning, where reinforcement learning means rewarding actions that lead to correct final answers. So after the training pipeline, Figure 4 shows how the team manufactures tough questions through a 3-step data synthesis flow. The left panel builds a knowledge graph, which is a network of facts connected by relations. The middle panel samples a focused subgraph to anchor a specific task. The right panel injects uncertainty, meaning the system deliberately adds ambiguity or similar entities, so the question becomes harder and tests deeper reasoning. Okay. Figure 5 shows how reinforcement learning is wired end-to-end, so task attempts generate rewards that flow back into training. A rollout means one full attempt from planning to final answer. The top flow links the async rollout service, rollout worker, trajectory storage, reward service, and automatic synthetic data. The dashed block on the left contains simulated and real environments that deliver observations. The dashed block on the right lists the tools the agent calls, including search, visit, file parser, Python interpreter, and Google Scholar. So Table 1 compares systems across major deep research benchmarks and shows broad leadership by Tongyi DeepResearch. The table groups methods into classic React agents versus full deep research agents, which matters because the latter include planning and tool use as first-class behaviors. The shaded bottom row highlights Tongyi DeepResearch with top scores in most columns, including about 75 on Xbench Deep Search. Frames peaks near 91, and Browse Comp and WebWalker QA land in the mid-40s and low 70s respectively. Alright, 2 takeaways stand out. A fully automated agentic pipeline, from mid-training to post-training with reinforcement learning, reliably teaches long-horizon planning and tool use, and the staged environments make reinforcement learning stable, which translates into strong benchmark wins with an efficient model. The broader implication is clear. Open, scalable deep research agents are becoming practical. Thanks for listening. That is it for this episode of the AI Research Roundup. I am Alex.